Hello everyone, my name is Aurelien. I am a sales engineer in the French sales team. And I'm here to tell you about a great customer story that we have with, the slide says, a leading European bank, but I was allowed to tell you that it's a major French bank that has a black and red logo. Type that on Google, you will probably find out who I am talking about. What was the customer need at the beginning? This is a bank. So what do banks do? Banks love to store money and to keep money. So of course, here the goal was to save money by aggregating the different storage solutions that they were using at the time. So they wanted to have one single solution that will become the go-to solution for most, if not all, of their users. The two main ideas to reach that goal were to propose a lower price per terabyte. This particular bank does not provide the internal storage solution for free. They bill their own internal users, they bill their colleagues based on usage, just like AWS does for the rest of us. So here, the goal of the Scality platform was to propose a lower cost per terabyte per year. The second method to drive adoption of that new solution was to facilitate adoption. Those of you who are customers at AWS may have noticed how easy it is to use their solution. You want to start an instance, click a button. You want to store some data, click a button. You want to spawn resources, click a button. It's always easy, it's always available, and this is how they make money. So the idea for our customer here was to facilitate adoption for their own users so that they would not have any choice but to use the simpler, cheaper solution. This bank built their private cloud on a Scality product. They used the Ring product, which is an infrastructure product. And the Ring is a great solution when you need to store several applications or many applications with many different workloads on the same platform. The Ring is a product that scales very well, almost limitless. And so this customer was able to move more than 2,000 applications. So this is to date, today in 2025. They were able to move more than 2,000 applications to one Ring platform. So it includes database backups. This is by far the biggest use case in terms of volume. It includes financial market data. As you know, banks and other financial institutions are held accountable by governments and other regulation agencies to keep the history of the transaction that happened, where money moved, by who, for what reason, and the history is stored on the Scality platform, on the Scality software-based platform. Another use case is data lake. So this is to aggregate data to train AI on. Document management system. So I'm talking about bank statements. I'm talking about official documents, things that need to be kept for a long time and that are kept with integrity thanks to the Core 5 features that Paul mentioned at the beginning. Fifth use case is developer artifacts. So like any IT company, they have developers and they need to store data. And last but not least, media. Media, this is a use case that we love at Scality. Why? Because it's a high volume and low constraint use case. A video is going to be buffered to a content delivery network most of the time before being played. So we don't have we don't have aggressive constraint for that use case. Plus, it's high volume. And since Scality licensing is based on usable terabyte, this is great for us. The architecture that they choose for their internal cloud has actually 6 different platforms, 6 independent platforms. 2 for each of the geographical regions that they have. So 2 in the US, 2 in Europe, and 2 in Asia. 2 for each region, because for each region they have one production platform, which is the one that most applications are going to use. and one disaster recovery platform. So just before a question was asked about the difference between synchronous and asynchronous replication, here, for each region between the production and the disaster recovery platform, asynchronous replication is used. Those 6 platforms are integrated together. They are not accessed directly by end users. Instead, the customer built a software system around the Scality platforms that will direct the workload of a new application automatically towards the correct platform. So basically, it detects where the user is and is going to send the data to the correct platform, the nearest platform, based on the location. On top of that, I mentioned asynchronous replication between production and disaster recovery. Those of you who are familiar with S3 APIs know that to enable replication for a particular bucket, for example, you need to make some specific API calls to enable the replication to allow reading on one platform and writing on the other one. So it's not complicated for a tech-savvy user, for an IT person, but it can be a little bit hard for someone who is not used to working with APIs. And this being a bank, of course, a lot of people are not going to be power users. So what the team responsible for the Scality platforms did was to build, as part of that integration, some checkboxes. Do you want your bucket to be replicated? Check the box. Do you want your bucket to be immutable? Check the box. Do you want your bucket to be versioned so that in case of human error, the file is not actually deleted? Check another box. And based on the box that are checked upon bucket creation, some API calls are going to be made in the backend and are going to enable the features that the end user needs. So now let's talk about a little bit about the challenges that this customer met. The challenges were pretty much what you would expect when you make a new solution available to a great number of users at a competitive price. The platform grew from 1 petabyte usable, so taking into account data protection, to 50 petabyte usable in 7 years. So that's from 2017 to 2024. He said, wow. So, I was mentioning a bit earlier the almost limitless capability, scaling capability of the ring. This is a good example. The customer that my colleague Nick talked just before, the SNES, they started already quite high and they went even higher. But here, for that particular customer, they started very, very low. Well, 1 petabyte is not that low, but comparatively low to where they are today. And they were able to do that online with no service interruption.
I have a question regarding the 7-year window.
Yes.
So I assume that they start with one type of hardware, and then over those years, this hardware was changed, right?
Yes.
And how does Scality ring handle this movement of data between old and new hardware?
Thank you very much for that great question. Scality, our first job is to protect your data and keep it available. So doing everything online is part of our development philosophy. Let's call it that way. So all operations are done online, and that includes software upgrades, that includes operating system upgrades, that includes expansion, and that includes hardware replacement. What we do when we need to replace some hardware is that we are going to list the components that are running on the servers that the customer wants to get rid of. And component by component, we are going to move all the data, all the configurations, everything from the old servers to the new ones. This is done not even server by server. This is done in parallel for all servers at the same time. So actually, not only is the operation done online, it's also quite fast. So we do it component after component with all servers in parallel. And when no more components are running on the old servers, basically they pull the plug.
Thank you. And you in Ring, you provide as well this, let's say, global load balancing networking mechanism, or needs to be a external hardware like GSLB, I don't know, F5 hardware, or you have some implementation inside your hardware already?
At the moment, most of our customers choose to use either HA proxy or F5 load balancers
Okay.
to
Thank you.
manage at the same time high availability and load balancing.
All right. Thanks.
You're welcome. So 50-fold increase in 7 years, and the cost of success with the Ring is that you get unpredictable use cases. Some applications are going to be very well suited for object storage. Some applications that this customer saw appear on their private cloud were actually part of our list of validated applications. So of course it went well. But some other applications we did not know. Some other applications had performance constraints. Some other applications had very aggressive workload that actually disturbed normal operation for other users. So it was really the cost of success to so many different applications, and it was almost a mess at some point. So how did we solve the different issues that we had? Two things. The first part was to improve our software. Ring is a powerful software. It's already powerful out of the box, but it's also powerful because it's a very modular architecture. It's easy to scale. Ben was mentioning it when he was talking about the leading US bank. It's easy to scale in different dimensions. You need more storage, you just add storage. You need more compute, you just add compute. You need more throughput, you just add throughput. So here, we were able to handle more complex workloads with higher service quality by simply scale one part of our software, one subcomponent. We increased from 8 threads internally to 32 threads internally, 4 times more power, same hardware, same CPUs, and we were able to provide better service. So actually, the cost of that software improvement for our engineering team was quite low. It was only a reconfiguration. The second improvement axis was architecture improvement. The Ring is a product that starts at only 3 servers. When you have only 3 servers in one cluster, you need those 3 servers to take part in all components. Monitoring is done by the 3 servers. Storage is done by the 3 servers. Access is done by the 3 servers. Everything is done by everyone. When you have a 50 petabyte platform, of course, it does not work anymore because some components are going to scale badly above 5 or 10 servers. Some components are going to require more power than others, so they need to be actually on the 50 or 100 or 150 servers. So we had to do some work, actually. So sometimes we have to figure out which components had to run on the entire cluster and which components had to run on a subset of servers. And by doing that, we solved maybe 3/4 of our issues. And for the last components that really need horsepower, we had the customer buy extra hardware for those components, just to dedicate hardware to those components. But as you will see in the slides after that, the customer was more than happy to buy extra power for a system that was working so well. So the results, some numbers, 100 petabyte usable deployed across the 6 regions, 200,000 S3 buckets, 300 billion client objects. Okay, this is a really big number. It's about something like 0.5% of AWS worldwide, this number. So it means that the single private cloud of one customer is already almost 1% of AWS worldwide. 1 billion client operations per day, which is not that much actually, because this is spread across so many servers, across so many regions. that when you compare it to operations per second, it's not, when you convert it to operations per second, it's not that high. But over the course of one day, it's an impressive number. And the most important number, probably, is that they reduced the cost per terabyte per year by 75% compared to their previous solutions. And I'm going to be honest with you, the main driver for cost reduction is that before they were not using one system, they were using a mess of systems. Each team had budget and bought their own system separately. So it meant multiple maintenance contracts, multiple hardware failures, multiple space saved, because you can never fill a system 100%. So when you combine all of that, plus the fact that Scality software runs on standard servers that are intrinsically low-cost servers, the result is a factor of 4 in terms of cost. So it's one of the customer stories we are proud of.
Aurelien, you mentioned that there were 2 rings, I guess, per region, one for DR, one for production. Are they stretched rings, or are they asynchronous replicated rings?
Production is a stretch, so it is still available in terms in case of a data center issue like power outage or whatever. So production is stretch, and disaster recovery is asynchronous with production and is single site, because they don't really care if they use the disaster recovery platform. Since production is going to still be up. So it's a mix. It's a mix of both production stretch and DR async.
And did you mention that there were multiple tiers as well in the solution, or it's all single tier?
No, as of today, it's all single tier, but who knows what the future is made of? We'll see. So far, it's one level only. Yes.